So welcome back. We were discussing a unique problem of psychrometry, namely adiabatic mixing. So how to solve this problem? That is what we are going to discuss in this with the help of one small and simple numerical. So this is the objective of this video. So please open your psychrometric charts so that we understand the concept in depth. So let us take down the problem. It is let's assume that we have the outside here, which is let us some moisture, which is at let us say the room here. Let us say room here, which is maintained at 15 degrees centigrade, dry bulb temperature, and 13 degrees centigrade wet bulb temperature. And let us say that its flow rate is 30 cmm. cmm is cubic meter per minute. So this is one air stream, and let us say that it is to be mixed with the fresh outside air, the fresh air, fresh or outside air, and it is having, let us say, the dry bulb temperature as 25 degrees centigrade and the wet bulb temperature as 18 degrees centigrade, and a small quantity of it is mixed. Let us say the volume flow rate of it is 12 meter cube per minute. Okay, and then we are interested in knowing, what are we interested in knowing, that after mixing, what is the state? After mixing, what is the state? Okay, so let us say we call this as state 1, we call this as state 2, and after mixing I call this as state 3. Okay, so this is what is the problem, that you are mixing this with this. So as we said that your mixing problem is represented like this. Okay, this is a mixing, state 3, state 1, state 2, and from the psychrometric chart, or before that, we can find the properties at state 1. So from the psychrometric chart, at state 1 you already know T1 and T1 dash, they are known. Okay, so open your psychrometric charts and find the remaining parameters. So remaining parameters means I want you to find what is the specific volume V1, what is the enthalpy H1, and you can pause the video and just see what values you are getting and then check the values which I am writing. Please pause the video, don't please copy it down. So you will find that the value of V1 is, you can confirm this, is 0.827 meter cube per kg. The value of H1 is around 36.85 or 37, and the value of omega is 0.0084. Okay, from the psychrometric chart you won't get exact values, but around this, even if you get, then they are okay. Okay, this is how you have to get the values from the psychrometric chart. Similarly, for the psychrometric chart, because you know the value of T2 and T2 dash, these are known, so you can get the point, you can plot the point on the psychrometric chart, and you can read the remaining values. Again, remaining values means what? V2, which is, let us say, it would be around 0.86, H2 would be around 51, and omega 2 would be around 0.01. Okay, again you have to pause the video and then write down these values. Okay, so that you will get a confidence of referring to the psychrometric chart and looking for the values. Okay, so now once you get this, what is your energy balance? Your energy balance is, first energy balance is M3H3 is equal to M1H1 plus M2H2. Now how do you find M1? So M1 you find by knowing the volume flow rate. And how much is the volume flow rate given? It is 30 what? 30 cubic per minute. And if you divide it by V1 is what? V1 is 0.827. You will get the value of M1 as, and just do the calculations and pause the video, do the calculations and come back, and you'll find that it comes to around 36.2. Similarly, for finding M2, we'll do the same thing. Write down the volume flow rate, which is 12 meter cube per minute, upon V2, which is around 0.86, and then we will get the value of M2, which is around 13.9 or 14. Okay, so this is how you calculate M1 and M2. And how do you calculate H1 and H2? Directly from the psychrometric chart, right? And then how to find M3? M3 is obviously by the mass balance. M3 is equal to M1 plus M2. M3 is obviously M1 plus M2. Okay, and that would be around 50.1 like this. Okay, so this is known. M3 is known, M1 is known, H1 is known, M2 is known, H2 is known. So the unknown is H3. We get the value of H3. So check what value you will get. Pause the video, do the calculations and confirm what is the value of H3. The value of H3 you must get should be around 40.8. And what is the unit? 40.8 kilojoules per kg of dry air. So this is the first part of the answer. Now the second part is you are required to find the moisture, that is specific humidity at 3. So again we write down the moisture balance. And now what is the moisture balance? M3 omega 3 is equal to M1 omega 1 plus M2 omega 2. We have found out the values of M1 and M2. We also know that M3 is M1 plus M2, right? So putting the values of omega 1 we had obtained directly from the tables, which is 0.0084, and this was obtained directly as 0.01. So from this you get the value of omega 3. So pause the video, find out the value, and you'll find that the value comes to be around 0.0886 kgs of water vapor per kg of dry air. Okay, so once you get the values of omega 3, so you have the value of, you know the state 1, you know the state 1, you know the state 2, some state, and you know the state 3. How you know? You don't know the state 3 now, but you know what is the value of omega 3, and you know what is the value of H3. So that would fix the state 3. And once you get the state 3, state 1 was how much? State 1 was, okay, so state 1 is closer here. So just a minute, a small correction. State 1 is recirculated here. So small correction here. Let me just rename them. Okay, yeah, right. So this is your state 1, which is 15 degrees centigrade, right? Let us say this is 15 degrees centigrade, and this is state 2, which is around 25 degrees centigrade. Okay, so once you get the state 3, then you can read the values. Once you locate the state 3 on the psychrometric chart, you can read the values of the temperature T3, which we are interested in. That is, we are interested in knowing what is the temperature after mixing, or of the mixture, which would be around, from the psychrometric chart, you find out, pause the video, find out what is the value of dry bulb temperature and wet bulb temperature after mixing. So you'll find that the value comes to be 17.5 and 14.5. Okay, so this is what we had learned. So please listen to the earlier video where we had discussed the concept of adiabatic mixing and solve the problem which we had discussed in this video. Will gain the confidence of handling the adiabatic mixing problems. Thank you. See you in the next video. Bye for now.